All right, thank you very much. Yes, indeed. So this session actually is scheduled to have quite a bit of discussion. So I hope to provide a bit of input for that, and we'll have plenty of time for discussion at the end. So I have been working on evaluating a build tool called Spec for the Key4hep turnkey software stack, and I'm going to share some of the experiences here. Maybe first up, I want to kind of start with kind of like an informal remark. Why do we actually even have to talk about these kinds of build tools here? It boils down to basically two problems. The first is kind of that we have a lot of software actually just. So I'm basically showing a graph here now where the nodes represent experiment-specific packages in the Key4hep software stack, and the lines are the dependencies between them, including the other hep-specific packages like root, so it grows a bit, and finally including like all of the general purpose and system libraries. It really becomes a very complex situation. So there are, however, tools like Linux system package managers who have solved this problem in principle. If it weren't for kind of like the second problem that we in the community face, which is the problem of reproducibility. So if my program, if my compiled code doesn't agree with your compiled code, we need some tooling to really be sure that we can get exact and reproducible results. And for this, like one of the most important thing is to have multiple versions that can coexist in order to compare and actually to be really sure to reproduce a build that's done on one machine on another. And this slide also lists a few other requirements, such as that are very, quite practical, sort of the deployment to cvmfs, which is sort of the standard thing, and to support software development use cases, sort of for people working on their laptops, which is also becoming very important. Also, just to mention some rough figures about what actually how big such a software stack is. Usually this contains about some 300 packages. For us, we have about 100 hep-specific packages and 200 general purpose libraries that they depend on in the end. And all of this, just as to give you an order of dimension, it's about 6 hours, so it can be easily be done overnight. But I think that's because that's not quite as big as some of the experiments of this. All right, so I mentioned the Key4hep project, which also has kind of like a guinea pig for evaluating Spec for hep software. I think the nice thing about the Key4hep is that it actually brings together projects which are up to some extent competitors, like the Future Circular Collider, Click, and ZepC, but to recognize that they actually can benefit a lot by collaborating on software tools. And this goes actually even a bit beyond the traditional common software tools like root or Geant4, but actually goes more towards having a common software framework for experiment software where that's possible. And I think it's important to give credit to DD4hep, the detector description toolkit, which was very successful. And I think building on this success, people realized that there's a lot of potential for collaboration here as well. I think that the one thing we don't quite agree on with DD4hep is the capitalization of the naming scheme. And we kind of have the naming scheme also to give some credit to DD4hep here, but well, that's that. So to introduce Spec, Spec is basically a package manager, does not replace kind of like the low-level build tools like CMake or Auto tools, but would be comparable to apt, Yum, or Homebrew. However, has a completely different philosophy, as it tries to install all the packages in a common prefix and then loads them when they're used as required. It originates from the HPC community, which also explains a lot of this emphasis on dealing with multiple configuration, with more exotic compilers, etc., and reproducible builds, of course. But by now, it's really seen a lot of adoptions also in other communities, including HEP. And I also want to say that Key4hep is not the only project contributing here. And I want to mention the electron ion collider also, which has been very perspective, but I can't give like credit to all of the contributors. So I also want to mention, which would kind of like, it's too much to fit into this talk to really talk about all the competitors who also think a bit about solving this problem of reproducible builds. But I want to refer to the linked paper, which has a very nice comparison, also, but it's written by the Spec developers, as therefore it may be a bit biased. One tool also I don't mention here is LZG CMake, which is kind of like the current CERN focused solution to build the LZG releases. So I also can't really go into can't explain all of the topics that Spec includes, but there is a very nice documentation and also a talk at a short talk at the recent C++ conference, and already a bunch of presentations also in the CERN context. There's a Slack channel for informal discussions, which even includes a dedicated HEP sub-channel. So just to introduce a few of the core ideas of Spec. The core concept really is the spec, like the specification of a package, which kind of like specifies how it should be or was built. Sort of this includes version, compiler, and options, and the same for all of the dependencies. To show an example, if to install kind of like this line basically expresses that I want to install root at some version between 620 and 622 using GCC at 9.3 for Linux, Ubuntu in the Broadwell architecture with the TMVA build option turned on. And it should, the build dependency is Python 3.8.2. Now this spec is of course somehow incomplete. Boot has much more build options. And so the first thing that Spec actually does is concretize this spec to obtain like a hashable concrete one, which I print here. So that there you can see that basically that mentions all of the build options, even the patches, which sometimes are necessary. The best practice is actually to push those upstreams, but for sometimes that's the best workaround. And the same thing for all of the dependencies. And finally, Spec kind of like assigns a hash to this whole concrete spec, including all dependencies. So that's how it tries to ensure that really the build is close to completely reproducible. Another important aspect are the microarchitectures, and Spec actually has there's another project which has grown out of Spec, which is this ArchSpec library, which tries to provide tools to reason about microarchitectures to assign these human readable names like Ivy Bridge, Skylake, Broadwell, and so there's a lot of support for building for actually different architectures. Just to mention, in our experience, like Broadwell seems to be comparable to what is used for the LZG releases, but the LZG releases are more compatible with older CPUs. So we have seen these illegal instruction errors on old CPUs, which have been known to work with LZG. So to build Key4hep as a practical example, and because one of the advantages of Spec is also the idea that it should be easy to use. Like to install the full software in 6 commands would be to set up Spec, which as an installer is basically really just a git clone of the repository, as it's Python based. The next step would be to set up the package recipes that describe kind of like our specific softwares. A lot of packages are already in the upstream package repository, but of course some things are really of specific interest to Key4hep. Finally, there's a step which is still necessary, which is to set some preferred package configuration options and give hints to the concretizer that I just mentioned to avoid errors. So this has been one of the developments that we are long awaiting in Spec, is a new concretizer that is smarter and can really be close to optimal to avoid errors, which to give an example, for example, an error would be that you want to build against Boost with Python build options set to on, but the concretizer couldn't figure out that actually this constraint has to be forwarded to Boost. And finally, we have you can use a bundle package to really install the whole software in one step, which will compile for a while, but finally it will end you up with a complete installation. One thing that's a requirement for us is also to have kind of like a setup script that's independent of Spec. I mean, Spec can be used to load packages, but since we also want to be kind of like comparable to the LCG releases, that was kind of like one development that is in Key4hep and is planned to be pushed upstream is this an automatic generation of the setup script that automatically get installed with the bundle packages. And for the nightly builds, what we wanted to do also was to have packages that can be installed with commit hashes as versions. Usually the Spec only defines master as a version and doesn't resolve the commit it points to, and wouldn't be rebuilt if anything changes. So you would also always have to remove the package and reinstall it if you want to build against master. So these are two developments that were missing for us and that we kind of like added in Key4hep. So talking about these package recipes and the low-level build system, how much work it actually is to maintain the stack in any build tool depends a lot on the individual package. You know, if this is standardized and well configured, this goes a long way to help reduce the maintenance burden. So what usually is very important is to have explicitly declared build options instead of just building stuff if the dependency is found. And that's I think this is also quite well known as there's an HSF node, and I really want to stress that I think we should as a community really emphasize and continue using these kind of templates and best practices. CMake is of course the clear favorite for C++ packages, and there's only a few packages that have more exotic build systems. I think one example is OpenLoops that uses cons and a few others. So this kind of, but not that's not directed to OpenLoops in specifically, but that does make the difference if adding a package to Spec is a work of 15 minutes or several days. So one decision that also needs to be made when installing like a software stack of this is where to draw the line between system and experiment software. So for the LCG releases, this is usually formalized with this HepOS libs project, which defines a list of packages that are expected to be on the system. And for Spec, we really try to build as much as possible, and mostly the dependency is here glibc. And there's a very interesting development in Spec that would allow compilers to have dependencies and build glibc with Spec, which would in the end allow basically a build, the same build to be used on all Linux platforms. And this in the end already kind of like a containerization. So for the default build on CentOS 7, we try to build as much as possible with Spec, taking basically only glibc and the kernel from the system, but just to kind of like experiment a bit with other build options. There was also Arch Linux, which has very well maintained HEP packages, even available in the system package managers, and this is also possible to pick those up with Spec, even though it's of course challenges a bit this idea of reproducibility, because you then need to rely on correctly describing the system package. Another important aspect is the cvmfs deployment, and I refer kind of like to Jakob Blommer's presentation linked here for the different approaches that can be used, and I think there's a lot of interesting development here. For Spec, we found that the best way is to use this rsync approach that is shown here, which is that the builder really has a complete read-write copy of the CA install tree, and changes the things in place, and then all the changes are just synced with the publisher from the builder. The downside, like this is quite robust. The downside is that it's more complicated to maintain multiple synchronized publishers like this. And we have we used the CERN GitLab CI to automate these kinds of deployments. And here, just to show that this cvmfs directory tree that we have it's already mounted in most places. You can try it out on LX+, either using the setup script to source the installation, or also to use it as an upstream Spec installation and use Spec to install packages on top of it. Now, most of the uses of Spec I described now are kind of like specialized to the software librarians, which so kind of like where Spec is behind the scene in order to install the software that you then use just using a setup script from cvmfs. But there's also the idea that actually Spec could really be part of your daily life as a developer, that you actually use it on the command line. And I think there are a lot of very interesting ideas in Spec. So there's this possibility of using the Spec dev build command, which basically really compiles local code according to the Spec recipe. So you don't, so it compiles your local changes, but for all the dependencies and stuff, it looks for the recipe to pull in the things. And there's been a lot of developments here, and there's also a dedicated channel on Slack for this development. Just to mention also, one part of this project is to go towards having the complete LZG releases in Spec, or at least evaluate Spec for this goal. And my colleague Ivan has really added a great amount of packages and generators. I think maybe making over 200 pull requests to Spec. So this is really already on a good way. And for now, we use kind of like this Key4hep installation as a test bed. And I just want to mention here also that if you can compile the software of like a scientific software, and if it compiles it, you're not really done. It's really important to validate the installation, because there are some really subtle issues and errors that can then appear at runtime because of build system differences. And I give a few examples. For example, that the packages can set default units at compile time, and then lead to wrong outputs. Finally, just to mention, there's in principle a mechanism in Spec that allows to create binary packages, but because a lot of HEPS packages are just not really very relocatable, for us this workflow doesn't really work that well. But I think I'm going to leave this for the discussion, because I'm running a bit out of time. Just to finish on the personal experiences, that the collaboration has really been very smooth. That Spec also now sees a lot of changes and a lot of people who pick this up. This is nice, but also comes with the problem that this rapid pace of changes means that to have a stable build, you really need to pin the version of Spec that is used, and then to cherry pick the changes. So that this was an important lesson that we learned. We are very looking forward to some developments, but already in the current state, it definitely has been possible to build the stack for us for kind of like this very decently sized project. And a final point is that the Spec recipes are really a very nice mechanism to persistify some build system know-how that otherwise is really just exists like in bug reports and things like this, so that that you can collect the problems that arise in non-trivial software from time to time. All right, and with this, I think I'm done.
Great, thank you. Very nice, and perfectly on time. Who has questions? Attila, you're the first one I saw.
Yeah. By now I have two. So let me start with the first thing that caught my eye. You mentioned that it is in the plans to possibly include glibc in the build. But then at the moment, how does Spec pull in the right compiler? So is when I say that I want to install a package with a given compiler, my understanding was that Spec would take care of setting up the compiler as well, doesn't it?
Yes, that's correct. I think actually I may have skipped this step because it happens automatically. But there's a command that Spec like this is kind of like a configuration option where you direct Spec to find a compiler, and then you can use it in the way I showed before. So I think that the command would be Spec compiler find, and then you could use compilers. Then Spec knows where to find, for example, the compiler GCC 9.3.0. This could be either from the system, or you also can kind of like bootstrap compilers and install them with Spec.
Okay, but yeah, in the end, this is sort of tying into my next question. I was absolutely convinced so far that Spec would be able to use binary packages, that it would be possible to pre-build packages and then just ask Spec to install something for us, which it would not build locally if we just download the binaries and put it in place. And I assume that in this setup, for instance, the command that you have here, that we want to use root with a particular GCC version, what would happen is that if that is not the native GCC, well, not irrespective of what the native GCC version of the installation system is, that Spec would just download root at that version, compiled with that version of GCC, and it would download GCC as well, and everything else that's needed. But now my understanding is different. So,
no, I think you're correct. So the idea is, I'm just going to pull up the slide about the build cache here again. The idea of Spec is that actually the advantage is that due to the hash that it assigns to your package, it's really possible for it to unambiguously say, okay, like this package is the same one as I'm going to compile locally. So definitely it is possible to kind of like, and there's no special thing about the Spec installation directory. So you could really just create a tarball of where you installed root, put this on a server, and then download it on another machine. So this is in principle no problem to do this kind of like binary distribution, and this is this mechanism I mentioned here. The only difficulty is I say with is this relocation, which works well for some packages, but I think that there's a lot of work to be done to make this work for.
Wait, but then Spec apparently doesn't have a post installation step like RPMs do to localize packages.
No. The idea is really that it's going to be installed in its prefix, and then all the paths are really set directly via our paths. So that's kind of like a principle of Spec. I mean, the Spec build cache tooling does have the same tooling to relocate them, but I think the philosophy of Spec is really not to do this.
Okay, thanks.
Thanks. That answers my question. Kevin.
Yeah, so I think my question also probably goes a little bit along the same lines as this relocation topic. But I had tried out Spack for a few things about a year ago, and I encountered a number of difficulties. And I think these are related to the assumptions that Spack makes, or at least has historically made. So I was wondering, is there work going on to make this more usable as a build tool for the typical HEP user case where you don't control the machine, you have limited resources in terms of CPU and disk, so you'd rather reuse things than rebuild them, and you may have multiple projects coexisting in different areas? Because these were some of the issues that I encountered.
Yeah, I think you're absolutely right that this has been a major issue for Spec, and it's not quite fixed yet. But I think the developers are aware, and this idea that the concretizer should really try to reuse more the installed packages, because that's something that can easily happen, because Spec is very picky about all of the dependencies. Is that you will reinstall packages that you have already that you think you have already installed. And I think for us, like reinstalling root over and over again is just not possible. But I think for the next version, this is really on the roadmap. This is actually already fixed in upstream Spec. And what we have been doing for Key4hep is to invest a bit in this, to basically do upfront a bit of this work to configure a Spec instance with I think this is this step I showed here, basically, where you configure basically your Spec install, so you actually have the same defaults and the concretizer works as expected. So I think what the road we're trying to do at the moment is to get around this problem a bit by testing a configuration and then providing this to users so that they can install packages. And I think a very nice thing is that you can also use the cvmfs installations as upstream, so that you can really use Spec to install on top of this.
Yeah, that is definitely nice. Thanks. I'll try to keep an eye on the progress here.
Thanks. Kyle.
Yeah, I had a few comments. One is that, and I see that Christian already mentioned this in the chat. Yeah, so yesterday at Supercomputing 2020, Todd Gamblin announced the release of 0.16, which does include the new concretizer. And the intention for compilers as dependencies is intended to come out as part of 0.17. The other thing I would say is regarding relocatability, for the majority of experiments, at least at Fermilab, when it comes to muon experiments or neutrino experiments, they absolutely require it. So they've been using relocatable builds of root, Geant, GCC, and hundreds of packages. So I would take some issue with the claim that many HEP packages are not relocatable.
Yeah, I think I'll take that back and say some, but I think that there's still some packages that are required for some experiments that where this is far off. But yeah, and a very good point about really this release has just been very recent and addresses. I mean, I think these issues that we talked about, then they're not. I mean, the new concretizer is there, but I think that still needs. It only lays the foundation to fix these issues. So I think this is planned for the next release.
Okay, thanks. Any more questions? I'm woefully not keeping up with the chat, but I think we got everybody.